Ars Technica. Hi everyone, Jonathan from Ars. We're here at CES 2016 at the Ford booth with Wayne Williams, who's an engineer with Ford Motor Company, and we're going to talk about what Ford's doing with autonomous driving.
So what you're seeing is one of a fleet of about 10 cars that we have right now. These are the cars that we use to do our testing and our evaluation of the algorithm. In the near future, we're going to expand our fleet by triple the size. So we're going to have 30 different cars, all outfitted with the same sensors that will allow us to do development and to actually do a fully functional, fully autonomous level 4 car.
Means it drives from point A to point B without a human touching the wheel.
And the way we do that, we usually describe it in 4 layers. So we start out with a sensing layer, and that includes those things you see spinning on top, those are LiDARs.
Right.
And that's what's generating this picture up there that you'll see of the world around it. That's how the car sees its world. So all of that sensor data goes into that sensing layer. That's then passed on to what we call a perception layer. A perception layer is, I got to make sense of all this data. Right? I have to take all of that raw sensor data and form a coherent picture of the world around me. Fully three-dimensional, fully 360.
And that's all done on board the car. It's not processing in the cloud or anything.
That's right. That's right. Once we have that picture of the world, we go to our third layer, which is decision making. That includes not only how I plan my path to get from point A to point B, but as I'm going along it, how well I'm following. How am I staying in the lane that I'm supposed to be in?
Right.
And in order to do that, the car has to generate commands. And we'd use that through what we call a virtual driver. Okay, that's basically the computers in the back that are taking all this information in, deciding how to turn the steering wheel and how to press on the gas or the brake, as the case may be. So those commands are then sent to our fourth layer, which is called actuation. And that says, okay, here's the steering wheel I want, here's the velocity, here's the throttle I want. Car, make it happen. And so that's the actuation layer, where the subsystems of the vehicle, the power steering and the powertrain, they all respond to those commands, and the car behaves accordingly.
So do you also have vision sensors on the car, or is the idea just to use LiDAR and then presumably like an HD machine readable map?
So let me answer a couple different parts of that. So yes, we absolutely rely on going out and creating a map of the area that we're going to drive in. And that's done using the same sensor suite that we have on this car right now. The notion of being able to take all that data, make sense of it, interpret what's there, and then respond to it in the time that you have available. If you're driving down the highway, that time frame is quite a bit smaller because you're at higher speeds. If you're in an urban environment, well, you've got a whole lot more time because your speeds are lower, but it's also a much more complex environment. So that's absolutely one of the challenges, is how do you get all that information, how do you make sense of it, how do you make those decisions, and then get the car to respond to those decisions that the virtual driver is coming up with. One of the things that we try to focus on is making the ride feel like there really is somebody in control. There's a really wide range of autonomous capability and how it feels to be the passenger in that. Some of them are very smooth, some of them not so much. And one of our focuses is on making that level of comfort to make it seem like this is just a normal person driving, a very good driver.
Do you think there'll be different personalities? So if I, say it's 5 years from now and I can buy a level 4 autonomous Ford, will there be, if it's a Focus RS, will there be, like a different, in the same way you have like a sport button, will there be like a sport autonomous driver button, or do you think it might just be one size fits all?
Drive me like my grandma, or drive me like my teenage son? Yeah. Actually, there has been some discussion of that. What we're focused on right now, though, is making sure that the algorithms themselves are functioning the way we want them to function.
Right. So it's a bit early for that.
It's a bit early for that, I think, yeah. So what you're seeing back here is this on the left is our computer cluster. So that's what's the virtual driver. That's the brains of the outfit over there. There's an Ethernet switch that's getting a lot of the information from the sensors and funneling it through to the brains. There's also the silver box here is the interface to the car's electronics. So when we generate those commands that I was talking about in the decision layer, we say, I want the steering wheel like this. That command goes to that silver box, And it's the silver box that talks to the power steering module on the car to make that happen.
And that presumably is much easier now that everything is everything's by wire, exactly. So it's about throttle by wire, braking by wire, steering by wire.
That's exactly right. The power switch over here is just so that we can individually turn things on and off as we need.
And then that's an extra battery to run all of it, right?
An auxiliary battery, yeah. That's part of the reason why we went with the Fusion Hybrid, is because we have that big battery underneath.
Okay, I'm not sure we have any other questions.
Okay.
So thanks very much.
My pleasure.